alaikum. In this video, inshallah, we are going to talk about the first part of fluid mechanics. We are going to introduce the density, how to calculate the density, what's meant by density, and how can we feel it in different states of matter. So first, we have to know that it's sometimes called mass density. You will find it mass density or density, and we will know why. Mass density is the mass per unit volume. So it's a mass in a given volume of a substance. So imagine that you have this cube of a material, okay? So this cube is a given volume. It has amount of mass. The amount of mass inside or filling this volume of the substance is called the density of the substance. Okay? So again, the density is the mass per unit volume. Okay. Coming to the formula, density is equal to mass over volume. So I'm going to divide the mass over volume. Since we said mass per unit volume, per means divided by. Okay, we give the density a symbol of rho. Rho, it's written like this, rho. Okay, equals mass over volume. What is the unit of mass? Yes, the SI unit is kilograms. And what is the unit of volume? Volume is measured in meter cube. So the SI unit of the density is kilogram per meter cube. Okay, so we can deduce the unit of the density using the unit of mass over the unit of volume. Sometimes we may find the density given in grams per centimeter cube. It's okay. We can use it like this, but when we are going to talk about the SI unit, we mean kilogram per meter cube. Okay, let's take some examples to show us exactly what's meant by density and how can we feel it in different materials. For example, I have here two cubes of the same volume. They are having the same volume. One is filled with so many balls, okay, great number of balls, while the other is filled with few number of balls. Okay, so which one is more dense? Which one is concentrated? So we will find that this one is more dense because it has more balls and the distance between them is neglected, so small. While here it's less dense, so it's less concentrated. So if we are making the volume constant, I'm going to compare what? Yeah, the mass of the two things or the two materials. So here, rho equals mass over volume. If we are fixing the volume, I'm using the same box. So here in this case, if the mass increased, what will happen to the density? Yeah, it will increase as a result. If the numerator increased, so the fraction or the number will increase. And if you remember from the previous video, we said that this is called what? In testing the variables, this is called controlled experiments. Controlled experiments. It means I'm fixing one of the variables and I'm changing the other to see its influence on the density. So I'm fixing the volume here and I'm changing the mass to see its effect on the density. Okay, so if I have equal volumes, the more the mass, the higher the density. Okay, let's move to the next point, which is the density and states of matter. As we know, we have three common states of matter: solids, liquids, and gases. And also we have plasma, but we are not going to study it now. Solid, liquid, and gas. We are bringing equal volumes of the three materials or the three states of matter. What about the mass filling this volume? If we take a look at the solid, we will find that the particles are so close to each other. The intermolecular distance is so small. So it means it will be having more mass because it has more particles filling this volume. So the mass will be very high. While here in liquids, the particles are farther away from each other. and in gases, they are so far away from each other. So in the case of gas, the molecules or the particles will be so small particles, so small in number and in mass. Which one is more dense? For sure, yes, the solid is more dense because it's more massive. More mass is filling the same volume, so it's more dense. Okay, so moving from gases to solids, we will find that the density is increasing. Okay, so if we make if we pour different solutions or different liquids, okay, in a test tube, such that they are having different densities, what will happen? For sure, we will find that there are layers formed of these liquids. Okay, which one is more dense, the oil or honey? Yeah, for sure, the one that's more dense is the honey because it rests downward. It's more massive, so it will be downward. Okay, more massive in the same given volume. Yani if we are bringing the same volume, okay, filling it with honey and oil, we will find that the honey will be more massive than oil. So this means that less the density, if the density decreased, this means that the object or the solution will float above the other. So if I'm going to compare oil with water, oil is less dense than water. Water is less dense than honey, and so on. As the density increases, the solution or the liquid will go downwards. Now let's talk about the formula again. We have rho equals mass over volume. So if we want to draw a triangle for this relation, it will be rho equals mass over volume. And mass is in kilograms, volume is in meter cube, and as a result, rho is kilogram per meter cube. Whenever we want to find any of them, we have to hide it from the triangle to find the relation. So if I want to find the density here, I will hide it, cover the density, we will find mass over volume. This is a division sign. If we want to find the mass, we will hide the mass. So we will find D times V since they are beside each other. So this means it's multiplication. D is the same as rho, rho times volume. But if we want to find the volume, I will hide the volume. So I will find mass divided by density or rho. Okay, let's practice answering these two questions. The first one here, what is the volume? So let's write everything. Volume equals question mark. I want to find the volume of 220 grams of an object. So for sure, since it's given in grams, so this number represents the mass of the object. So the mass is 220 grams with a density of 55 gram per centimeter cube, given that the density, which is rho, is 55 gram per centimeter cube. Okay, let's draw the triangle. So here we have rho, mass, and volume. Okay, I want to find the volume. I will hide the volume. What can you see now? Mass over rho, mass over density. Yes, that's right. So the volume is equal to mass divided by density. This means 220 divided by 55. And this will give 4. For what? What is the unit of volume now? If the density is given in gram per centimeter cube, this means that the volume is in units of centimeter cube. Okay, we don't have to change units here because everything is given in grams and centimeter or centimeter cube. Okay, so no need to change the units. Let's move to the last question. A cube measures 3 centimeters on each side. Okay, so as we know that the cube is having equal sides. So if I'm given one of them, it means I'm given the 3, okay? S equals 3 centimeter. Directly from this, I can find the volume. Volume of the cube is equal to side to the power of 3, or side times side times side, which is equal 3 times 3 times 3 means 27. 27 what? Centimeter cube. Okay, so I have the volume and has a mass of 25 grams. So the mass of this cube is 25 grams. What is the density of the cube? I want to find the density rho. Okay, directly, I don't have to draw the triangle now. So rho equals mass over volume. The mass is 25. The volume is 27. Dividing 25 by 27, it will give 0.93. What is the unit in this case? Here, the mass is given in grams. The volume is given in centimeter cube. So it will be gram per centimeter cube. And again, here we don't have to change the units because everything is given in the same unit. Since the density will be in gram per centimeter cube, it doesn't represent any problem, okay? But it's not the SI unit of the density. The SI unit is kilogram per meter cube. Okay, thank you.